Okay, class, we're going to solve this polynomial inequality here. F of x is equal to x to the fourth plus 2x to the third minus 3x squared is greater than 0. And we're going to write the final answer in interval notation. Okay? So let me explain. We have this function f of x. And our goal is to find the x values in the domain of that function that will make the y values, or what we call the range values or outputs, become numbers that are greater than 0. Okay? So let me just experiment for one moment here. Let's say that I plugged in x equals 1. Then if I plug in 1 into this function, I'm going to end up with what? 1 plus 2 minus 3, okay? Is that going to produce a true statement? And the answer would be no, because this is going to be the y value that results, and that y value would be 0, and 0 is certainly not greater than 0. Okay, that's a false statement. Okay, so I know that in the end, 1 would not be part of the final solution. Okay, now how do you begin solving inequalities like this? Well, we begin by first figuring out where the function is equal to 0. Okay, so we solve the equality. Okay, so anytime you solve an inequality, you first solve the equality. So where is the function exactly equal to 0? Okay, so now I'm going to set my function to 0. Oops. And then solve for x. I know that I can factor an x squared out, and that leaves me with a quadratic here. And then we can continue to factor. This is x squared, it really factors into x times x. This is going to now give me x, what, plus 3 and an x minus 1, and that equals 0. Okay? So this function f of x has zeros of 0, -3, and positive 1. Okay? Now, those zeros, of course, would help you get your x-intercepts. Okay? Now, those values, those x-intercepts, okay, they tell you where your graph is going to cross the x-axis. Okay? And so what that helps us do is helps us to find subintervals. Okay? So that allows us to find subintervals of f of x. And now that's going to cut our domain up. Here, let me just take a moment here to lower this. I just want to make it a little bit lower. Okay, and so now I'm cutting the x-axis at -3, at 0, and at 1. Okay? So we have 4 subintervals. X values that are less than -3, in between -3 and 0, between 0 to 1, and then greater than 1. Okay? Now, what we need to do is we need to determine what is the sign of the function on each of those 4 subintervals. Okay? So what is the sign, S-I-G-N, of f of x on each of those subintervals? Okay? Now remember that we said that we could do this with test values, or we could make a super fast sketch of our graph. Okay? Because this is a polynomial, we know that we could make a sketch very quickly. Now we know that x equals 0 is a 0 of multiplicity 2, right? Because really this equation produces x equals 0 twice. And this negative 3 is a multiplicity of 1. And this has a multiplicity of 1. Okay? So that means that at 0, 0, we're going to be what? Touching and turning. At negative 3, 0, we're going to cross. And at 1, 0, we're going to also cross. Okay? Now, we can also use the end behavior. Remember, x to the 4th is the LT. That's the leading term. And so we know that we're going to be what? Rising on the right, okay, and rising on the left. We know that at that 0, okay, we have a multiplicity of 1, and therefore that means that at the x-intercept, we're going to be crossing through. So the function goes from positive, then boom, it hits 0, because that's what the x-intercept tells me. And then it's going to change signs and become negative. But then, at 0, 0, we're going to touch and turn. So here at 0, 0, we're going to hit the x-axis and then stay negative. Okay, so the function on that subinterval is negative. Boom, it comes back to 0, then it stays negative. Okay, and then it's going to come to negative 3, 0. And since we've got a multiplicity of 1, we're going to cross through. Okay, and then it's going to go and meet this other portion of my graph. Okay, so now we know from the sketch, from negative infinity all the way to negative 3, the function's positive because the graph is above the x-axis. Between negative 3 and 0, the function's negative, okay, because all this portion of the curve is underneath the x-axis, right? So it would be lying in quadrant 3. And then between 0 to 1, again, the function's negative. And then greater than 1, the function's positive. Okay? Now, remember that at these three numbers, the function is exactly equal to 0. Okay? Now, the last thing we need to do is we need to read our sign chart, or our graph, whichever one you prefer, and then write the final answer in interval notation. So let me go ahead and do that right here. Okay? We're trying to find the x values in the domain. Okay? So where on this x-axis do we have y values that are greater than 0? So that means that on the sign chart, we're trying to figure out where there are plus signs. Okay? So that would be what? From negative infinity all the way to negative 3. But is negative 3 included? The answer is no, because negative 3, as we saw up here, makes the function exactly equal to 0, and that was indicated by this blue 0. So negative 3 doesn't make the function positive, makes it equal to 0, and therefore it's not included, and neither is any of these other values. And then we've got union from what? All the numbers that are greater than 1. So now it's going to be union from 1 to infinity, 1 not included. Okay, so that's how you do, or how you solve a polynomial inequality.